desired to be T means thyristor is desired to be turned off. Proper bias is applied at the base of the Q transistor. On receiving the signal at its base, the transistor Q starts conducting, which in turn applies negative polarity of the DC voltage V at the anode of the T, and simultaneously the positive polarity at the cathode of the T. This reverse voltage V immediately turns off the thyristor. Thus it is seen that Q acts as a switching transistor which is turned on only when the thyristor T is required to be switched off. There are two conditions which ensure turn off. Number one is the duration of the drive applied at the base of the transistor Q must be sufficient to cause turn off. Second condition is the auxiliary transistor Q must be driven into saturation state and remain into the state to cause turn off. In place of transistor Q, a pulse transformer can also be used to achieve the commutation. When a reverse polarity voltage of proper value is applied to the primary of the pulse transformer, the magnetizing current is reversed, which immediately turns off the thyristor. Diode D has been used as a freewheeling diode for providing low resistance path to the current due to stored energy in case of an inductive load. In external pulse commutation, both the pulse width modulation and pulse rate modulation techniques can be used, and the commutation failure can be overcome by the external pulse source. Another advantage of this process is that the commutation is independent of the load current and the DC source voltage E DC, the magnitude of the voltage V, the type of the transistor Q, and the duration of the drive applied at its base are the factors to be considered in designing this circuit. Now comes the next commutation process, which is called self commutation process. In this process, the thyristor is commutated by itself through the commutating components. This is also called the current commutation process. Initially, as soon as the supply voltage EAC is applied, the capacitor C starts charging, with its upper plate being positive and lower plate being negative, and it charges up to the voltage EDC as shown in this diagram. This is a circuit for self commutation process. Here the SCR automatically switched off by itself, and the circuit is so designed that the voltage across the capacitor automatically switches off this SCR as and when required. Charges up to the voltage EDC. The moment the thyristor T is turned on, C starts discharging through T. When C is completely discharged, it starts getting in the opposite polarity. This means the upper plate starts acquiring negative charge and the lower plate starts acquiring positive charge. This results into reverse biasing of the thyristor. Simultaneously, C also discharges in the opposite direction and reduces the current through the thyristor T to less than the level of its holding current. In other words, it can be said that the capacitor discharges current I opposes the load current IL, As soon as I becomes equal to IL, the thyristor T is turned off. As soon as the T is turned off, C again starts charging to its original polarity through L and the load. When C is fully charged, T will be on again. Now this thing we can see from the diagram. The moment T is turned on, C starts discharging through T. When T is completely discharged, it starts getting in the opposite polarity. This means the upper plate starts acquiring negative charge and the lower plate starts acquiring positive charge. This results into reverse biasing of the thyristor. Simultaneously, C also discharges in the opposite direction and reduces the current through the thyristor T to less than the level of the holding current. In other words, it can be said that the capacitor discharge current I opposes the load current IL. As soon as I becomes equal to IL, the thyristor T is turned off. As soon as T is turned off, C again starts charging to its original polarity through L and the load. When C is fully charged, the T will be again. From the above discussion, it is clear that the thyristor, after switching on for some time, automatically switches off, and after remaining in the off state for some time again gets switched off. This was the circuit for self commutation. Here now this capacitor C is responsible for switching off the thyristor as and when required, and it makes this automatically switch off when the voltage across the polarity of this capacitor is responsible for switching off or on as and when required. This is the basic principle of self commutation. Now comes the last technique of switching off a thyristor, which is known as auxiliary commutation. Auxiliary commutation: in this process, an auxiliary thyristor is required for commutation the main thyristor. Obviously, the auxiliary thyristor is of much lower rating than main thyristor. Tm is main thyristor and Ta is auxiliary thyristor. Now this thing we can see in this diagram. Here Tm is the main thyristor and Ta is the auxiliary thyristor, and there is a diode D1 blocking diode, and an inductance L is connected in parallel with the auxiliary thyristor, and capacitor C is connected in series with L, and D2 is the freewheeling diode which is connected in series parallel with the load. So this is a complete circuit diagram for the auxiliary process. T is the auxiliary. Initially, when the DC voltage EDC is applied to the capacitor C is charged to a EDC, with its upper plate acquiring a positive charge and the lower plate acquiring a negative charge. As soon as Tm is turned on, C starts discharging through the Tm, D1 and L. After C has completely discharged, its polarity will be reversed. A reverse discharge of the capacitor C will not be possible due to the blocking diode D1. Now at this moment, as the lower plate C has a positive polarity, the auxiliary thyristor Ta will come in conducting mode. As soon as Ta is triggered, the reverse polarity is obtained across the Tm, because C will try to discharge through Ta. It is clear from the above explanation that the commutation is achieved by reverse voltage applied across Tm. This process is also known as commutation process and is commonly used in chopper and inverter circuit. Now after this I shall give you some basic detail of series and parallel operation of thyristors. First of all, I shall give you what is the necessity of the series and parallel operation of the thyristors. Although thyristor is a powerful handling electronic device, but sometimes a single unit is not sufficient to handle huge electric power such as transmission line. In such cases, it is necessary to connect a number of thyristors in series to handle high voltages, such as number of thyristors are connected in parallel to handle high currents. The series parallel combination of thyristors is used to handle huge electric power. Sometimes series or parallel connection of thyristors is also adopted to minimize the cost of the system. It is because sometimes an individual unit of the higher rating may be costlier as compared to a combination of the multi thyristors of a lower rating. String of a thyristor and its efficiency. Now, what is the meaning of string? The string of thyristor, the multi thyristors connected in series or parallel form a unit known as string of a thyristor. String efficiency. What is the meaning of string efficiency? The ratio of the total current of leak voltage rating of the whole string to the individual current voltage rating of the SCR multiplied by the number of units in parallel series in the string is called string efficiency. If the n is the number of the thyristors connected in parallel series connection, then for parallel connection, string efficiency is equal to current rating of the whole string divided by n multiplied by current rating of the individual thyristor. Similarly, for series connection, string efficiency is voltage rating of the whole string divided by n multiplied by voltage rating of the individual thyristor. So it is important to note that to obtain the highest string efficiency, all the thyristors in a string must have identical characteristics. But in actual practice, it is not possible to get thyristors of the absolute identical characteristics. Even the SCRs manufactured in the same batch do not have the identical characteristics. In case then the deviation of the characteristics of different units, it poses the problem of variation in the distribution of the voltage or current among the individual units connected in series or parallel combinations respectively. Therefore, as far as the possible matched units are selected to form a string. Now, first of all, series connection of the thyristors. When a cathode of the thyristor T1 is connected with anode of thyristor T2 and cathode of thyristor T2 is connected with the anode of T3 and so on, this arrangement is known as series connection of the thyristors. For simplicity, a string of 3 thyristors T1, T2, T3 connected in series. These connections are used for high voltage operations. Now suppose if V1, V2 or V3 are the respective voltage ratings of the T1, T2, T3, then the voltage rating of the string V will be the algebraic sum of the V1 plus V2 plus V3. The string voltage can further by connecting more number of thyristors in the string. So we shall give you some unequal distribution of the voltage. Number 1, variation in the leakage current of the thyristor. Second is turn on and turn off time of the thyristor. And these are the main two problems for unequal voltage distribution among the connected thyristors. So this was some additional topic which was about the basics of which I have you given. So mainly our topic commutation and triggering on the methods of the SCR I have covered. With this we conclude this lecture. Thank you.